Jai Hind everyone. I am Anshul Kumar Panchbhaiya, Assistant Professor Mechanical Engineering Department, Ajay Kumar Garg Engineering College. Today I am going to discuss the topic in machine design. Basically we are going to discuss today is Introduction to Design. This course has been run in AKTU with the subject code KME 602. So let's begin with the introduction of design. This is the syllabus content of machine design. This is the syllabus content. As you can see, the syllabus comprises of 5 units. The syllabus comprises of 5 units. Unit 1, Introduction to Design. Basically, the Unit 1 introduction is the introduction to, you can say, it's related to design of static load. Basically, here we are focusing basically on the design of static load. These are the contents which needs to be covered in a design of static load. These are the all content, like definition is there, design requirement of machine elements is there, design procedure is there, standards are there, then designation of steel is there, selection of preferred size is there, and design again static load is final conclusion of this chapter. Now the second chapter is design against fluctuating loads. So this is the Unit 1. Then in Unit 2 we are going to discuss the topic named as rivet joint and welded joint. The design procedure of rivet joint, the design procedure of welded joint, stresses induced in a rivet joint, stresses induced in a welded joint. These are the topics which are going to be covered in Unit 2. In Unit 3, also there in Unit 2 there is a topic named as shaft. Shaft is also going to be covered, and in shaft we have a topic named as keys also. Keys are also there. Shaft and keys are going to be discussed in this particular chapter. Then in Unit 3 we are going to discuss the gears are there. Basically this is Unit 3 comprises of a topic named as gears. Gears is a combination of two types of gears are there, spur gear and helical gear. These two gears are going to be discussed. Their design procedure, what are the beam strength in a spur gear, then what is helical gear, how the dynamic load takes an important role in a helical gear. These are the topics which are going to be covered. Then in 4th unit we are going to discuss the topic named as bearing. Bearing are basically two types, sliding contact bearing and rolling contact bearing. These types of two bearings are being discussed. Then again same, the design procedure of a rolling contact bearing, failure of rolling contact bearing, reliability. These are the topics which we are going to discuss in bearing. Now 5th chapter is we are going to discuss is IC engine and friction clutches. These are the topics which we are going to cover in Unit 5. See, the important thing is the data book. The design data book is allowed in the examination. So it helps us in remembering all the formulas, because there are number of formulas in the particular subject, and it's literally next to impossible to remember all the formulas. So design data book help us in remembering all the formulas, including the designing procedure also. So this will be allowed in the examination. Data book will be allowed in the examination. So the unit comprises of subject comprises of 5 individual units. Unit 1, Unit 2, Unit 3 and Unit 4 and Unit 5. Unit 1 is design of static and dynamic load. Unit 2 is rivet, welded and shaft. Rivet joint, welded joint and shaft. Shaft also have keys in it. Then 3rd unit is gears. 4th unit is rolling contact bearing, sliding contact bearing means bearings. 5th is IC engines and friction clutches. Now these are the textbook references. The book V.B. Bhandari and Sharma and Purohit. This is the best book of machine element design. There are also number of books available. As you can see here, number of books are mentioned, but this is one of the best book in which you will get all the contents and all the topics related to particular subject. Now what is a machine design? The thing which we need to know that what is a machine design. Now you can see machine design is defined as the use of a scientific principles. Use of scientific principles, technical information and imagination in the description of a machine or a mechanical system to perform the specific function with maximum economy and efficiency. Machine design is defined as the creation of a new design, improving the existing one. See what is happening here. Basically, what you are doing, if a engineer is designing any component, what is he going to do? He is going to see that what component I am going to design, what are the scientific principles which will be applicable to the designs, what are the technical information or description I required for that design, and then I need to implement all those concepts to achieve my component with maximum economy and efficiency. Then I will say I have designed the component. This is the machine design concept, means use of scientific principles, technical information, imagination, and then collaborating all these things in a particular procedure, you will get a designing component, but that component should perform maximum efficiency with maximum economic. Because see, if you manufacture a component, it is very costly, and the same component is being manufactured by the other company and it is cheaper and having the same configuration, then it will lead the customer will buy the different component. So what we are going to do, we are improving day by day, and we are improving the design. We are improving the design with the existing one. See, the existing one is, suppose this is a pen. This is the existing one design. Now someone has manufactured another pen by improving some of its configurations and also reducing the cost. Then this is a new design, you can say. So this is the definition of a design, means use of scientific principle, technical information, imagination, and then mechanical system to perform smooth function with maximum economy and efficiency. So this entire definition is of a design. Now before going through the basic procedure of a machine design, we must know what is the condition for a safe design. We must know what is the condition for a safe design. Now what will be the condition for a safe design? See, there are two types of stresses in a system. See, one is when you can say, I'll write it here. One is sigma permissible and one is sigma maximum induced stress. So for safe design, if the design is to be safe, then sigma maximum induced stress should always be less than sigma permissible. And now what is sigma permissible? Sigma permissible is nothing, it is sigma allowable, how much stress is being allowed divided by factor of safety, or you can see SYT or SUT divided by factor of safety. This is sigma permissible. Now what I have explained here. See, if you are designing a component, there will be a stress named as permissible stress. For a component to be safe, this permissible stress should always be less than the maximum induced stress. Now for solving any numerical, what you need to do, you need to calculate the sigma permissible. And if you are calculating the sigma permissible, then when you need to do, you need the formula to write the sigma permissible. And it will be nothing, it will be sigma allowable upon FOS, or you can say yield strength or ultimate strength divided by FOS. So if you have a component having permissible stress greater than the maximum induced stress, then you can say the component is safe in design. The component is safe in design. Now if you have the machine design definition, if you have the condition of safe design, then what you need to do, you need to know what is the basic procedure of a machine design. What is the basic procedure of a machine design? So let me see what are the different procedures. So what's the market survey? The market needs to be surveyed for designing any component. Means if you are making any product, you need to go to the market. You need to check whether that what material is available for making that product. So there will be a survey of the market. Then you need to specify the specification of the product. Means you need to define the specification of the product. Specification means, suppose you are designing a shaft. You are designing a shaft and you need to specify that what torque is this going to be what torque is going to be generated, or what is the power transmitted by the shaft. Torque kitna, how much amount of torque will be generated. So this is the function. What twist is going to be generated in a shaft. This is the function. Now third step is study alternate mechanism for product. Selection of proper mechanism means you need to select a proper mechanism to make that component. Suppose you are making a gear, you need a proper mechanism. If you are making a shaft, you need a proper mechanism for making the shaft. Then next, to prepare a general layout of the configuration and select joining method for individual product. Means you need to make a general layout. General layout in the sense means, suppose you are making a component, you need to make what will be the first step. Second, you have to prepare a layout and what will be the different joining process. You need to mention that. Then you need to design individual components. Suppose a engine is being designed, there is a number of components involved in an engine. Then you need to design an individual component. Finally, you need to assemble that. Finally, prepare assembly, as I've said, and detailed drawings and modified drawings after testing a prototype model. Means if you have prepared a model, you need to test that model. If it is performing up to the mark which you have for which you have prepared it, then it is okay. If it is not performing, then you need to modify the product, or you can say you need to modify the drawing, or you need to change the drawing dimension of the product. So what are the basic requirement of a machine element? If we have gone through the basic process, what is the basic requirement? It should have a good strength. It should be rigid in nature. It should have a wear resistance. It should have minimum dimension and weight. It should have manufacturability. It should have safety, conformance to standard. It should be reliable, reliability, maintainability, and minimum life cycle cost. These are the requirements. If you are making any machine element, these are the requirement of the machine element. These are the basic requirement of the machine element. So in this reliability, conformation to standards, if you see these points written anywhere, then you can say this is the basic requirement of the machine element. Now, let me again go to the basic procedure of a design of machine element, because it is an important topic, very important. Many times the question comes, write down the basic procedure of design of a machine element. So what I have written is specify the function. That means shaft designing, power, torque, what is the power, what will be the torque, what will be the angle of twist. These are the function of the specific element. Then what are the forces acting on the element? Means suppose you are designing a two-wheeler and a person sitting in it and a person sitting at the back. Then what will the forces acting on the element? What are the, you need to determine those forces. Then after determining the forces, you need to select the suitable material for the element. You need to select a suitable material for the element. Then after selecting the element, you need to determine the different modes, failure modes. Means if it is a ductile material, which theory of failure will be applicable. If it is a brittle material, which theory of failure will be applicable. To determine the basic theory, means failure theory. Determine the failure mode, how it can be failed. You need to know the theory. Then after that, you need to determine the geometric dimension of the element. Suppose there is a shaft, you need to determine the diameter of the shaft, dimension of the element. Then modify the dimension for assembly and manufacturing, and check design at critical cross section. Means if you have completed the element, then you need to assemble that element. After assembly, you need to check the design at critical cross section. Means there will be a critical part where you will say the component can fail from here. Then what you are going to do, you need to determine, you need to check the design at different cross section, critical cross section. Finally, prepare working drawing of the element. After completing all these steps, then finally you need to complete the working drawing of the element. So this is the basic. This is an important question. Why I am saying it is important? Because it has been frequently asked in an AKGEC examination. In many examinations you will find this question. What are the basic procedure of a machine design element? Now, again I have written all these things. Specify function, design of machine element, determine the forces, select suitable material, determine failure mode of element, determine geometric dimension, modify dimension. These are the all steps which we have seen here. This has been written in this is the image, and this has been written in the bullets form. Finally conclude from here. So these are the steps. Means, see, whenever you are designing any component, always remember the safe design condition. Always you need to remember the safe design condition, and the safe design condition is sigma maximum induced stress should always be less than sigma permissible. The stress may change. Suppose it is if the theory is been applied on the basis of shear stress, then you will say shear maximum induced stress should always. But the thing is, the permissible should always be greater than the induced stress. Then material selection. This particular portion plays an important role. Material selection plays an important role. See, material selection, you can see here, there is in material selection what I have written in the first point, selection of proper material for the machine components is one of the most important steps in the process of machine design. The best material is one which will serve the desired purpose at minimum cost. Factor considering while selecting the material. See, the first 2 points says that the selection of material is a very important step in the process of machine design. It's a very important step. And the best material is one which will serve the desired purpose at minimum cost. Which will serve the desired purpose at minimum cost. Factors considering while selecting the material is, number one is availability. It's a very important factor. Availability. Material should be readily available in the market in large enough quantities to meet the requirement. Means material should be readily available in the market, and it should be in a large quantity, enough quantity so that you can meet your requirements. Then availability of its cost. Cost means it should not be very high cost, or it should be at a nominal cost so that your product will become economic. Then third point is mechanical properties. What is the mechanical properties? You can say mechanical properties, mechanical consideration. Mechanical properties means manufacturing consideration. In some application, machinability of the material is an important consideration in selection. Whether you are able to machine that element, it's very important. Where the product is of complex shape, castability or availability of the ability of the molten metal to flow into intricate passage is the criteria for material selection. Suppose I am doing a casting, or I am making a complex shape using a casting process. So I need to make sure that the ability of the molten metal to flow in the intricate passage, means the path which the molten metal is going to follow is the criteria for the material selection. In fabricated assemblies of plates and rods, weldability becomes the governing factor. Means suppose you are manufacturing or fabricating some plates and rods and you need to weld that, then weldability, how much weldability is there, it's an important factor. So these are the manufacturing consideration. So if I see the material selection consider of all these factors, then you can say you have selected a proper material. You have gone through a proper material. Then when you have gone through the basic procedure, you have seen the basic procedure of design, you have seen the material availability, material selection point, then you have seen what is machine design, but you can see you have also seen the condition of safe design. Then there are standards and codes. Now you see what is written. Standardization is defined as a obligatory norms, means norms to which various characteristics of the product should conform. Means, see, suppose you have manufactured a product, it should be under standardization category, means it is fulfilling all the norms which has been made. Suppose you have manufacturing a carbon steel, it should follow BIS system, Bureau of Indian Standard System. So standardization is defined as an obligatory norm to which various characteristics of product should conform. The characteristic include material dimension and shape of the component, method of testing and method of marking, packing and storing of the product. Means, see, before manufacturing any component, you need to follow up the standard and codes which are available for that material and for that particular component. It should be in the tolerance limit. It should follow the fits criteria. Everything testing of the product means it should fulfill all the criteria which are mentioned there. So codes are necessary, standard and codes are necessary for all this concept. So what is the significance of a standard and codes? Means these are been said or designed on for the, you can say for the manufacturing of the component. These codes needs to be studied, that whether the material is fulfilling that criteria or not. Then you can say standard for engineering drawing of the component, means standard of the material, their chemical composition, their mechanical properties and heat treatment, means everything should be discussed, seen properly. Suppose there is a grey cast iron, the grey cast iron is represented by Fg. The plain carbon steel, it is represented by 40C8. This is a representation of plain carbon steel. First, this alphabet is for carbon percentage. Carbon percentage. This is the combination of plain carbon steel. Plain carbon steel. This is manganese. Its multiplication factor is 10 and its multiplication factor is 100. Carbon is 100. Means 40% carbon and 8% manganese. If I write it in percentage, I will write it as 0.40 and then I will write 0.8. Dividing 40 divided by 100 and 8 divided by 10. This is the combination of plain carbon steel. Wherever I have seen Fg, it is a grey cast iron. What is this 150? This is the tensile strength. The strength of the material, tensile strength. So means in Newton per mm square. Tensile strength in Newton per mm square. This is the grey cast iron. Fg1, the number of ultimate tensile strength. See, it is an ultimate tensile strength. SUT. Suppose there is written as FE300 and FEE 300. So this representation is for brittle material and this representation is for ductile material and this represents the strength. This is SUT and this will be SYT, because the brittle material fails due to you can say fracture, SUT, and the brittle material failed due to yielding, SYT. So these are the representation. So you need to check the standards, that whether you are selecting a component, you are following the standards, you are following the codes which are being referred for the particular material. So these are the standards, these are the codes to identify. What is this? 40C8. This is a plain carbon steel code, BIS, Bureau of Indian Standards. Then there alloy steel is also. If I talk about alloy steel, what I am going to write? Alloy steel, two types, medium and low alloy steel and high alloy steel. If the chemical composition is greater than 10%, less than 10%, medium and low alloy steel, greater than 10%, high alloy steel. So what I am going to see, this is again, if I am taking alloy steel component, then I need to check the standards, I need to check the representation, I need to check all the codes which have been mentioned for that particular component. So what is this? These are the standards and code. Very important factor for selecting any material. You need to check whether it is fulfilling all the standards, whether it is fulfilling all the codes. I think it is clear. So what next? Suppose there is a topic named as preferred numbers. For this, preferred numbers. Now, what is the significance of a preferred numbers? Basically, preferred numbers follow a general progression series. See, suppose if you need to design a motor, or you can say a shaft which transmit power from 5 kilowatt to 15 kilowatt. So preferred numbers helps in designing the range of the products. The size of the product is general term which include different parameters like power, transmitting capacity, load carrying capacity, speed and dimension of the component such as height, length, width and volume of the product. These parameters expressed as kilowatt or RPM. So suppose you need to design a component in a range. Suppose I said design me a motor of which will transmit the power of 5 kilowatt to 15 kilowatt. So you can take the help of preferred numbers. This is preferred number follow the GP series. Preferred number follow the GP series. So if the preferred number following the GP series, then you need to know that which series is going to be applied. Which series is going to be applied. So there are number of series available for preferred number. These are R5 series, R10 series, R20 series, R40 series, and R80 series. These are the number of series of a preferred number. And every series has individual multiplication factor. For R5 series, a different multiplication factor. R10 series, different multiplication factor. R20 series, different multiplication factor. R40 series, different multiplication factor. R80 series, different multiplication factor. So we have different multiplication factors. So how I am going to decide these multiplication factors? These are being given here. See, you can see the system is based on the use geometric progression to develop a set of numbers. As I have said, there are 5 series: R5, R10, R20, R80 and R40 in a percentage of 56, 26, 12, 6, 3. So you can see there R5 have 1.58, then 1.26, 1.12, 1.06, 1.03. These are nothing. These are the multiplication factor for individual series. These are the multiplication factor for individual series. Suppose I told you that manufacture me a shaft ranging, or you can say a motor ranging from 7 kilowatt to 70 kilowatt with the help of R5 series. So what you are going to do? You are going to see the multiplication factor. It is 1.58. You have the multiplication factor as per the series. Then what you are going to see? You are going to check what is the minimum power, that is 7 kilowatt. What is the minimum power? That is 7 kilowatt. Then what will be the next? It will be 7 into the multiplication factor 1.58, because I am designing it as per the R5 series. The next will be 7 into 1.58 into 1.58, 1.58 square. The next will be 1.58 cube, and so on. And we will go until we reach this value. We will move forward until we reach this value. If we reach this value, near to this value, then the different range of series is available. And we can say this has been designed on the basis of preferred numbers. This has been designed on the basis of preferred number, on the basis of series R5. Now, if we have, suppose I have 5 to 15 kilowatt, 15 kilowatt, and I need to design on the basis of R10 series. What I am going to do? I am going to begin with 5. Begin with 5. The next will be 5 into, what is the multiplication factor as per R10 series? It is 1.26. Then again 5 into 1.26 square, and so on. And we will move until till the point where we can say, yes, we have reached the maximum value, that is 15 kilowatt. We have reached the maximum value, that is 15 kilowatt. So what is the significance of a preferred number? What is the significance of a preferred number? If we have a component, and we need to design the component, if we have a component and we need to design a component on the basis of a particular range, then we need the help of a series. And this series is basically termed as preferred series. This preferred series comprises of different series factor, that is R5, R10, R20, R40 and R80. Now, individual series have individual multiplication factor. R5 has 1.58, R10 has 1.26, R20 is 1.12, R40 is 1.06 and R80 is 1.03. And on the basis of this multiplication factor, on the basis of this particular factor, we can decide the range of the components from minimum to maximum. From minimum to maximum. Now, if we have gone through all these things, then we need to know the different types of load. then we need to know the different types of load, so that we can understood the concept of what? Of design of static load, and again the next chapter, design of dynamic load. Design of static load and again design of dynamic load. So we are going to discuss the type of load in the coming next lecture. Thank you.